Yes, class. Good evening. Am I audible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, others, Shaima, Jesleen, Ali, are you all people not able to hear or what?
Yes, ma'am.
Yes, ma'am.
To respond whenever something is being asked. Otherwise, separately, I have to ask each other. Okay, in the last class, we started with a moment of inertia. So, different figures were there and different values of moment of inertia we had. So, yes, Shaima, let's start with you. What is the moment of inertia for a disk when the axis is passing through the center and perpendicular to it?
I equals mr square by 2.
Correct. Mr square by 2. Very good, Shaima. Sabiha, when the axis is parallel to the diameter for a disk. Yes, Sabiha. Sabiha,
Yes, ma'am.
yes, what is the answer for this? When the axis is parallel to the diameter for a disk, what's the moment of inertia, Sabiha?
About it's the about 1 mil.
What? Sabiha, your voice was breaking. Please answer properly. What's the moment of inertia for a disk when when the axis is parallel to its diameter? Yes, Sabiha. I think for the second or third time you have unmuted yourself in this entire session, and that too you're not answering properly. Yes, Giobita.
I equal to mr square divided by 2.
Incorrect. Jesleen, you've answered. Say that answer aloud.
Mr square by 4.
Mr square by 4. Mr square by 2, already Shaima answered it when it was perpendicular to the plane. Parallel to the diameter, I have told you that this is mr square by 4. Okay, Alina, for a hollow cylinder. Yes, say. Yes, Alina. Alina Aftab. Moment of inertia for a hollow cylinder. No, Alina, we can't hear you.
Ma'am, can you hear me now?
Yeah, now it's fine. Say. Alina, you are not audible. Firstly, you can type the answer. Sabiha has answered this. Jesleen has answered it. Okay, correct. Sabiha and Jesleen, both of you are right. Mr square. It is simply mr square. Alina, you answer for the solid cylinder. Quickly, Alina, answer for the solid cylinder. Type it. Correct, Alina. Mr square by 2. No, Sabiha, that is for, you are answering for the sphere. For the solid cylinder, it is mr square. So, mr square by 2. So, mr square and mr square by 2. Okay. Sphere. Ali, solid sphere and hollow sphere.
Ma'am, solid sphere is 2 by 5 mr square
And
and
hollow?
hollow is 2 by 3 mr square.
Correct. Very good. So 2 by 3 mr square for hollow and solid 2 by 5. Then we had seen the cases of rod also. If the axis is perpendicular to the plane and passing through the center, moment of inertia is ml square by 12. And if it is towards the end, one of the axis, towards one of the ends, it is mr square by 3. Class, learn this entire table which we have discussed, or all these figures with their axis, with their final formulas. This is very important, and you will be getting mixed questions. Circle will be there resting on a solid cylinder, circular ring placed on a hollow sphere. Like this, you will be getting questions. And you will be introduced to the concept of radius of gyration today, that we'll discuss it. But these have to be learned by you. See, I didn't ask this part because, see, at least if you know what are the analogs, you can convert. If I say work done is equal to F dot S, so you know force can be written as tau, linear displacement can be written as theta. So this part you can at least make. But if you don't remember these formulas, then you'll not be able to complete the question further. So this also we have discussed. Yeah, we were on conservation of angular momentum. So yes, class, in conservation of angular momentum, it's similar to conservation of linear momentum. In conservation of linear momentum, we had the external force equal to 0. In conservation of angular momentum, we'll have the torque, external torque equal to 0. Now, in the case of linear momentum, all these, this portion, just revise the Newton's second law. I think you'll get a slight revision and a slight basic concept of this also. That will be helpful. So it's better if after today's class, just take out 2 minutes before you settle down. Just read and revise the Newton's second law. It will be beneficial. Okay, because this is very much similar to the conservation of angular momentum. Now, in angular momentum, the angular momentum remains constant because the rate of change, what is dl over dt? We know it is the rate of change. So you know that rate of change of angular momentum is 0. So angular momentum is constant. And what's the formula of angular momentum? I omega. How to remember this? You remember P is equal to mv. That's enough. You just convert it. You know angular linear momentum can be written as angular momentum. You know linear mass can be written as angular moment of inertia. You already know that linear velocity can be written as angular velocity. So just convert it and you already have these formula. You don't need to remember these. Remember the basic formula which we have studied till your laws of motion. Some students have done work, energy, and power twice. You all remember those formula. Momentum was there in that only. Laws of motion we have studied, right? So learn all these things from there and just convert in rotation. This thing I have told you in the last class also. So rate of change is 0, rate is constant, so it means I omega is constant. Means examples also, to have two examples we have seen that when one quantity increases, in order to keep the constant, the other quantity changes. It's like I into omega is some constant, some value it is there. Suppose this decreases down, so this increases up, so as to make this constant change. This cannot change. You remember their product cannot change. The product of moment of inertia and the angular velocity, it cannot change. It has to be fixed. So this is a question. I'll discuss it myself only, but it's a lengthy question. You write it by yourself, make a rough sketch, make a rough figure, then I'll discuss it with you. First, you write this question 1. After this will come under the topic of conservation of angular momentum. Just text me done once you have written the question so I can start with the discussion. Only Ali has written. If any other student has also written, please keep on texting me done. Then I'll start with the discussion. Okay, so I'm discussing. If anyone is writing, please text because only few students have responded with a done. So I'm assuming we have completed. Ali, Alina, Jyobita. So a man stands on a rotating platform with his arms stretching horizontally. Arms are stretching out horizontally, holding a 5 kg weight, holding a 5 kg weight in each hand. What is this condition here? In the first case, initially, what is the case? Initially, there is a person who is standing on a rotating platform and the arms are stretched out. This is the case. Then there are two weights, each 5 kg they are held and the arms are completely stretched. So they must be having some weight which is provided also. Correct? What's given in the question else? It says the angular speed of platform is 30 rotations per minute. Written, this is platform and this is the axis, this must be the axis and it is moved. Then it says the man then brings his arm close to his body with a distance of each weight from the axis changing from 90 centimeters to 20 centimeters. Means initially it was 90 centimeters, this separation. Now what is happening? Finally, in the second case, finally, the person is there standing on this rotating platform only, but he has brought the arms now closer to his body. It means both the weights are still held in each of the arms like this. But now the distance has been reduced to 20 centimeters. And this is also bringing with some velocity omega 1. This already had the velocity as, this is omega 2. This had the velocity as omega 1. All the values are given. We know, I have read the values of. The man then brings his arm close to his body with the distance of each weight from the axis, changing from 90 centimeters to 20 centimeters. It's a very important question, class. Mark this as very important when you're writing. The moment of inertia of the man together with the platform may be taken to be 7.6 kg meters square. What is this? Is the moment of inertia. So in the first case, we already have the moment of inertia of the entire setup. Means man with the platform moment of inertia is there. What is the new angular speed? What is omega 2? Omega 2 is unknown. This is 5 kg, 30 rpm, 90 centimeter. Moment of inertia. Everything is mentioned. In the second case, 20 centimeter, weights are same. Then we already know angular momentum is conserved. So it's a very easy question of you see. See, what is the angular momentum here? I omega 1. Now we just have to expand this I, that's it. We just have to expand this I. See, moment of inertia of the man with the platform is already given. I am writing it as IP. Person and platform. So moment of inertia of the man with the platform is already given. So I'm writing this as IP. What is IP? IP is representing the moment of inertia of man with the platform. Problem is that I cannot put omega 1 here. Can anyone tell why? Why can't this be my answer for this, for the first case? Can anyone tell? And open the cameras, other students also, only Alina is following the instruction. Yes, class. This is incorrect, which I have written. Why is this incorrect? Can anyone answer? Just think. Very good, Ali. Ali has answered it correctly. Because the inertia is of the two objects also. These are also held on the arms of the person. So if I just say it means only the person and the platform, that's it. But no, we know in our situation, we have two objects also. And they are holding a mass also. If these objects are holding a certain amount of mass, they will be contributing to moment of inertia also. So how do we have to write this? We have to include the moment of inertia of this also. Let's say R1. This is R1. Both the distances are same. So for the first block, I am writing MR1 square. Moment of inertia's formula. I hope you remember MR square. This is MR1 square for the first. Okay. For the second one also, I am writing MR2 square. Fine, class. So MR1 square, MR2 square. This also has been included. Now this has been included. The total moment of inertia is there. Omega 1, equation 1. Now complete. Clear, class? Now come to the second. Here also, L2 is equal to I omega 2. Again, this is equal to IP, means moment of inertia of the man with the platform. That won't change. But since this distance has changed, this moment of inertia will also change. So this will be, let's say, some R2 I'm writing for 20 centimeters. Value we can put. So mr2 square plus mr2 square. Why twice? Because two objects. For both of them, I'm writing. And this is omega 2 equation 2. Tell me, class, any doubts till here? Because now it's just calculation and very, very simple calculation that also two people are going to answer because omega 2's calculation will take a lot of time. First, tell me, is it clear or not till here? Yes, I'll explain it again. Wait, let me explain it, then you all can answer. See, what happened? Nobody should write right now. Just understand first. Then you can take your time, copy. See, a person is there who is standing on a platform with two weights he is holding, and both the weights, he has spread his arms along the side. He has stretched both of his arms and a long radius has been created of 90 centimeters and he is rotating. So what will be the angular momentum? I omega. Now we have to expand this moment of inertia. Angular momentum is I omega. So we have to expand this moment of inertia. What will be the moment of inertia? Moment of inertia of man, moment of inertia of this mass, moment of inertia of platform, moment of inertia of this mass. But in the question, we already know that 7.6 kg meter square is already given for the moment of inertia of man plus platform. So two things are covered, man and platform. What all are left? This and this. They are left, these two blocks. So mr1 square is the moment of inertia of this block because this is the axis which we have taken. And mr2 square, mr1 square here, sorry, mr1 square. So both the moment of inertia is also taken. So all the four moment of inertia are now included. Within this IP, which is 7.6, we have included these two as per the question. And these two are also separately taken, mr1 square plus mr1 square. Oh, I have written mr2. This is also one. This is also mr1 square. Same radius. Same, everything is same in this. It could have been unidentical. In that case, you have to write different. Every time it's not necessary that it is given. You can bend your arm slightly, another can be stretched out. So the body can be asymmetrical, you know this. Okay, so this is the first equation. Now what he is doing, he is bringing his arms closer to his body. And when he is bringing his arms closer to his body, so the radius decreases. Again, angular momentum is I omega. So moment of inertia will be same, person plus platform. That is already given 7.6. It is not changing. But the radius, since the radius is changing because now the arms are brought closer to the body. Now the distance between the object and the axis is slightly less. It is 20 centimeters now. We have to include the new moment of inertia also. So mr2 square, mr2 square. All the four moment of inertia are again covered. Two within this IP. In this umbrella, we have both of these included and then these two, omega 2. Now, you know, angular momentum is conserved. There is no external torque which is acting in our system. So, you know, angular momentum is conserved. Means both the angular momentum you are taking. That is IP plus, I'm straight away writing it as 2mr1 square into omega 1 is equal to IP plus 2mr2 square into omega 2. This is your task to find. You can put the value 7.6, it will be 7.6 plus 2 into mass was 5. Radius was 0.9 meters because 90 centimeters was there. So class, you have to convert it, right? Omega 1 is equal to IP is 7.6 plus 2 into 5. R2 is now 0.2 because it is 20 centimeters into omega. Omega 2 you all have to calculate. That is the task. This is also given. This was 30 rotations per minute, right? This also let me write. So you just have a simple linear equation with one variable. If this also I'm going to solve, that what you are going to do. Right? At least these simple calculations you all should be able to do. You answer this, tell me what are your answers. But first, write down from you. And whatever doubts you have, please get it clarified right now. I hope you've understood. It's a very important question. It involves all the concept what we have studied in the past two classes. Write it, all of you. Okay, Shaima has answered 58.875 RPM. Others also, please confirm this. I'm starting with radius of gyration now. So, what is radius of gyration? Basically, this is also a distance which we take from this axis where this rotation occurs. So, from this axis of rotation, suppose this is the point where the whole mass of the body is concentrated. So, the separation of this point from the axis of rotation, which is called the radius of gyration. We have studied about center of mass. Some of you, center of mass is still left. I remember Alina, Ali, Vyopita, and Abir. Abir has, I think, left or she wasn't there. So you people have to do it. I have talked last week. We couldn't have any class because you all had some engagements. On Friday, Vyopita was not available, so that's why the classes couldn't be there. But center of mass is left for few students, and that has to be done. I'll try if we can have the class tomorrow itself. Let's see. So, basically, in radius of gyration, you know the way we have the center of mass. This is actually the radius from where the center of the whole entire mass can be concentrated. So it can coincide with the moment of the center of mass also. It can be independent also. So formula is the same, mk square. Moment of inertia is mk square. This k, this is the radius of gyration. This is the radius of gyration. I is equal to mq square. Okay. Like if you have to calculate the radius of gyration of a disk of mass m and radius r. See, you know what's the moment of inertia? The best method is that you know how to calculate the normal moment of inertia, mr square. See, if it's a disk, it will be mr square by 2. I know this. And I is equal to mk square for radius of gyration. This also I know. So what can I do now? Both are giving us the same quantity, that is the moment of inertia. So what we can do? We can equate both of these. mr square by 2 is also giving the moment of inertia. Mk square is also giving the moment of inertia. So like this, you can calculate the radius of gyration. Now see, equate these two. Mr square by 2 is equal to Mk square. M cancelled. What is K equal to? R by root 2. That is the radius of gyration. That's it. This is the answer. For the sphere, you are going to answer. Okay? For the sphere. And take it as a solid sphere. Okay, take it as a solid sphere and answer. But first write down all these points. only Shaima has answered, and the answer is right. Calculate the radius of gyration for a sphere of mass m and radius r. What did I tell you? You all remember the formula for sphere's moment of inertia? 2 by 5 mr square. I is equal to mk square. Mr square into 2 by 5 is equal to mk square. M gets cancelled. K is equal to r root 2 by root 2 by 5. Write it, then we'll start with rolling motion. That is the last topic for this chapter. Yes, Shaima, we can. Just inform the team once. It's okay from my side. I'll take it tomorrow. Just to inform the Learnivio team once. Okay, fine. Yes, class. Let's start with rolling motion. I think by now you must have written it. See, class. Understanding of rolling motion is not difficult. It's just that whatever you have still studied till now, you have to combine it. That's what you have to keep in mind. See, there is one case where you have studied translation motion. In your motion in a straight line continuously, you have been studying about translation motion only. So if there are 3 points, these 3 points are just for reference. See, A point is on the uppermost side, O is at the center, B is on the lowermost side. So velocity of the center of masses of each. See, class, for those who don't know, center of mass is basically a point where the entire mass of the body is supposed to be concentrated. It means in simple terms for understanding right now, you can remember this as, even if I replace this entire mass with just a single point, that point will be able to fulfill all the requirements of that body. Means that point, that single point will be able to deliver the velocity, also acceleration for the entire body, everything. Okay, so that is what is the center of mass, though we'll be discussing in detail all those who have not done, especially this is for Alina, Ali, and all. So though in your class, Jobita, it was done, but since you're saying you weren't in the class, it is for you also. You also can do it again. Okay. So these 3 points are there. So these 3 points are just taken for reference. Velocity, center of mass, velocity of the center of mass of point this, and point B, velocity of center of mass. When the body just moves straight, that is translation. If the body simply moves straight, it is the translation, which you have studied, and all the theories of Newton's laws are applicable in the inertial frame. Secondly, rotation. We have completed today whatever things were required. Velocity becomes r omega. That also we have studied. And the body moves in a circular fashion where there is where there is a central axis located, and around that axis rotation occurs. That is your rotation. When you combine this, you get a third category, which is rolling. Like, take the example of a block. If I drag the block over a table, if I drag the block over a table, I'll be getting translation motion. The fan, the blades of the fans, the blades of the fan, they are revolving around the fan, which is situated with an axis at the center attached to your ceiling, and all the blades are rotating. So that is rotation motion. But in the third case, take the example, best example is the motion of tires of vehicles. When that vehicle is moving, the tires are rolling, not translating, not rotating. Rolling means both the action is doing. The tires are rotating also. You can see whenever there's a motion of a tire, that they are rotating also, and the vehicle is moving forward because there is a translation also. That is what is called a rolling motion. Okay. So here also both the things will be combined. So look here, class. When we are talking about the velocity, just look at the figure A. A figure is sufficient. Look at point A. Here, point A here. So velocity of center of mass in translation, V is equal to R omega in rotation. So in rolling, what will it be? VCM plus R omega. If you look at B point, it is still VCM. But here, the velocity is always tangential in rotation motion. We have studied that. In translation, there is no rule. In translation, wherever the body moves, in that direction, the velocity is there. So that's why B is straight. But see here, since the velocity is tangential, so right now at this point, this is also tangential. So it is in opposite direction. So at this B point, you have the net velocity as VCM minus R omega. This is very important for you to remember. Though don't take it as a formula, take it as a case. Wherever you'll be getting the case, you have to apply it like this. Take reference points. Okay, reference points will help you. Write down this, then we'll see acceleration part. Okay, look at this acceleration part now. See, ACM is the acceleration of the center of mass of this point A. ACM for this center O, and again 3 points of references in translation. This is the case of translation. This is rotation. So this is alpha r. Remember, the tangential acceleration is alpha r. This is the centripetal acceleration. Correct? And alpha r here. So this is the case of rotation. So combined effect gives us rolling. So if I have to find out the acceleration at point A, so this is ACM plus alpha. If I want to find out for B point, it is. If I want to find out for B point, it is ACM minus alpha. So this is not a formula which you need to remember. Remember the steps. Different cases can be there. Write down this two